Okay. And what we did was, until now we have distribution. Until now, what we have done is given R and B in the ECI frame, find A, E, theta, capOmega, I, and smaOmega. So this we've already found. This is, you can replace this with H as well. Right? E for E. What we have done until now. H or A.
Or A.
Until now, what we have done is computed H, right? Did we compute H? So just check your notes. We computed H. We also computed I, right? And we that was step. So this was step 1 through 6. Step 7, what we did was we introduced this vector n is equal to k cross with H. Okay? So I want you to get an idea of what this k cross with H is. If it helps, what you can do is you should get a printout of that the orbital elements from NASA's website, or you can just refer to your textbooks.
Or gymnastics.
Yeah, let me pull this up. Maybe that was likely
I guess like 25 pages. I was trying to get this so that I can just print one on page, but it's not
This is what we have been referring to. Okay, this figure. Just zoom in on this. Okay. Is it visible? Now, what is this vector n? Where is this vector n?
Line of nodes.
Huh?
Line of nodes.
Line of nodes in what direction? Line of nodes itself is, it's a line, right? What direction is it? Look at this thing, line of nodes. The line of nodes will have, right, it's the ascending node direction. Okay, it's this line. this point to this direction. Because line of force in the other direction would be, if you look at the other direction, what is this K?
This is.
Guys, pay attention here. What is this K? There?
That's in the North Pole.
Right, but what is it there? Look there and tell me what is K?
It's Z.
It's the Z. Okay? So this K is Z. Everybody, please make sure you understand that. This K direction is nothing but the Z direction. Okay? You understand why this, what is this N direction?
What is that?
What is this N?
And it's the perpendicular to
You understand why it is this vector? This vector is N. You understand why? Why is that vector N? Pay attention here.
it's when the two planes meet.
Why is it K cross H? Why is it Z cross H?
Because it's two
It's two vectors, okay? This. So this is,
Isn't it oh, it's perpendicular.
it's perpendicular to both.
K and
Perpendicular to what? Why is it not H cross K? And why it is K cross H? What would be H cross K? Huh? It would be in the other direction. You understand why that is the case? So your H cross, it's always in the right hand sense. Okay, this vector, so here it is N vector, right? It will go from K to H. If it would went from H to K, it would be in the other direction.
okay, so just for clarification,
Huh?
so Z is right?
It's the K direction. Here Z is K.
Yeah, okay, and then H is what it would be off the
If you look at this line is what? This line is in what plane? Plane. What plane?
The XY. This thing that you see.
Oh, the most like the name of the
Is it orbital line?
Look there and tell me.
We live in the orbital line.
Look there and tell me, guys. Which plane do you see that line?
Isn't it the echo?
But it's really the line intersects both planes.
Exactly. It is in both the planes. Right? Do you see it is in both the
It
planes?
was a trick question.
Guys, don't laugh. Jayla, please pay attention.
I was yes.
Don't distract anybody. Okay? Please. It is in both planes. Do you see that? Huh? You don't see it?
The line in the middle is where the intersection between the orbital plane and the equatorial plane. So really he wanted you to say that the line in the middle is in both planes. It's where the line in the middle is where
The gray,
equatorial plane
the
and
beige thing is the beige thing is what plane? It's the equatorial plane. The green hatched thing is orbital plane. So the line is in both planes, right? Now if you have perpendicular to these planes, what is Z? Z is the perpendicular to
the equatorial plane.
equatorial plane. What is H? The orbital plane, right? If a line is there in a plane and if we have two perpendiculars, that line should be perpendicular to both planes. Both those H and K. You see it?
Yeah.
So that is the state N direction.
So I trying to oversee like doing like
So do this. So how do we do X, Y? So this is X, Y, Z. Okay? How do we do X, Y, Z? Other hand. What is X? Huh? What is X?
X is
What?
One hand at a time.
X.
One finger at a time.
X, Y, Z.
Huh?
X, Y, and Z.
So can you do that? If you do this, if this is your X, if this is your Y, this has to be in this direction. The Z has to be in this direction. X, Y, Z. If you do X, Y, Z, if you do X, Y, Z, it will go in the other direction. You see it? Yes.
I'm not really seeing it on this picture.
Mm.
So K, we're using Z instead,
Mm-hmm.
and then H is the same base that we're.
Right. So you
that
do
means
this.
that
Do this.
plane is-
You do this. Where does your thumb go? You see it?
Okay. Maybe the lines are just
You see the thumb?
weird. Yes.
The thumb is the Z direction. Okay.
Thumb is facing towards me. So the line goes, it's not going down.
It's going. It's coming down.
It's going towards the. Okay.
From this point forward. From this point forward, the orbital body climbs the orbital plane. It goes above the equator. That's the reason it's called ascending mode.
Okay.
You got it?
Yeah.
So the plane is like this. This is the equatorial plane, and this is the orbital plane. Okay. The line of intersection is the line of moves. All right. So just make sure you understand this. This is very important. It will be a very, very important question in your exams. This is step 7, and then step 8 is compute n. How do you compute n? How do you compute this n?
Just take the magnitude.
Just take a magnitude, okay? Or you can do n ordered with it, okay?
So,
Now your omega, capOmega, if you see capOmega is defined with respect to that's n, okay? So you can say omega is
inverse cosine of nx over n.
right cosine inverse nx over you see it?
There's an X or Z.
X. How do you get nx? How do you get nx?
Nx is
That'll be when you, in step 7.
What is nx?
Oh, it's
What is the justification?
N cosine. H dot cosine.
It's
You got it.
n
It's N cosine.
dotted with here it is x, but we can say it is I is equal to
Oh, yeah.
n. I is 1 cosine.
yeah.
The thing up there.
Cosine.
capOmega. Okay? N dotted with I is nothing but an x. The projection. It's always a scalar projection. Okay, this is scalar, right? Nx and n are both scalar. And this is where we use scalar projection. Just like we use the scalar projection in terms when we did I, we're just doing the same thing. Yes.
What is capital I?
Capital I is x.
Okay.
So this ijk is similar to xyz here. Okay, this k is z, I is x. Okay. Nx is n cosine omega, which implies, so this is the justification. Okay. Now we have calculated omega, capOmega. Step 10. We introduced this e term 1 over mu.
That is about step 9. In the book, it's talking about that there's 2 cases.
Right, right. We'll talk about the 2 cases later. But this is the justification. So what is going to happen is, I'll talk about the 2 cases. Okay. It's the 2 cases will exist for I and why do they have 2 cases? What is this? What is special about cosine?
Cosine
Hmm.
is cosine.
Hmm?
Is the x component.
What is special about cosine? Can you?
Well, it depends on like the quadrant, right?
It depends on the quadrant. So cosine of omega is also equal to cosine of negative omega. You remember? Cosine of omega is equal to cosine of negative omega. So this, when you do this, this could be positive or negative. That's the reason we have 2 cases. You see it? So you don't know, right, whether it's positive or negative. It could, this omega could yield 2 values. And that is where we'll discuss the 2 cases. Now, this is the formula for E. We have come across this formula when we derived the trajectory equation. You can go back and refer to that. From this formula, you can, what is known here? What is known or what is given? Until now, what is known or given? Huh? H is known, H is, we computed H, B is given, R is given, this R can be computed, mu is constant. So you can compute E and you can compute step 11. This E is what?
Energy direction. Is it eccentricity?
This is the perigee direction. Okay?
Oh, it's just
But it is the eccentricity vector. Eccentricity vector is the perigee direction. But how do you compute this E?
back.
From this.
It's
Simply-
the magnitude.
E dotted with E. It's the magnitude, yes. That's how it is. Okay. Now try to do this. Try to tell me what is. How do you calculate what is omega?
Omega is the angular velocity.
Huh?
The angular velocity.
Not that omega. Small omega.
Small.
The small omega there.
Angular momentum.
That's it.
No, that's the
Angle between the x-axis and the line of others.
So Nathan, we'll discuss about your E here. Okay? There's a reason I brought this E. So this check. What is this omega?
That's the angle between the y-axis.
Look at
the
that.
line of nodes and the line of inversion.
Right. So line of nodes. What is that? This it is this vector, right?
Yeah.
And can I say this vector? That is an E vector. Okay. If I say N dotted with E, what would this be? Huh? Yes, it would be N E cosine omega. Exactly. You see it? It is a vector. It is the angle between this N vector, right, and this E vector. This perigee direction is the E vector. Yes. Perigee direction is the E vector.
Oh.
Okay. Whether you take it as this E or the unit vector E, you're still going to get the same angle. The angle is the same. Okay. So now, how do we solve for omega? Omega is what? Cosine inverse n dotted with E divided by N.
Isn't in step 9 when you have the NC is equal to N cosine, isn't that omega as well? That symbol?
This one, this is capOmega, this is smaOmega. So that's how we capOmega, I and smaOmega is what we use to represent. And finally, now tell me what is theta? You have calculated so many angles, now tell me what is theta? How would you calculate theta? Yeah, we know it's true normally, but
Between R and
yes, that's correct. So how do we write it?
R dot
R dot E is equal to
R
Re cosine theta. That's it. So you have R dotted with E is equal to Re cosine theta, and this implies theta is simply cosine inverse R dotted with E divided by. Okay. So now, have you calculated all the orbital elements? Check if you have calculated. So we calculated H, A, I, we calculated E, we calculated capOmega, smaOmega. So A and H is, if you know one, you can calculate, you can get the other. From E, there's a relationship between H, A, and E, right? What's the relationship? You guys remember from your lesson? H is?
You said H, E.
H is a specific angular.
Now, what is the relationship between H, A, and E?
It's A.
Mu A 1 minus
E squared.
E square, right? So if you know one of them or two of them, you can calculate the other. You see it? So if you know H and A or H and E, you can calculate A. If you know E and A, you can calculate H. Okay. So H, recall, just refresh your memories. What does H or A characterize for the orbit?
The size.
The size of the orbit. You understand? What does E characterize?
The
It's shape.
The shape of the orbit. What does theta characterize? Characterize. That is what it
The
is.
position of the orbiting body.
Position of the orbiting body. What do these two characterize? These three? The angles. What do they characterize? What do they characterize? Understand the question. What do they characterize?
The right ascension angle.
Oh.
capOmega is the right ascension.
Yes, but that is what they are. What do they characterize? Angle between the planes or the. They characterize the orientation of the orbiting plane with respect to the equatorial orientation. Okay. So given a plane, if you are given a plane, what are the three elements you need?
Say it
Orientation
again.
of the plane.
Orientation
Two
of the orbiting plane with respect to the equatorial plane. So if you see that now, if I give you the plane, what three are known? If I give you the plane, what would I give you? If I give you the plane,
One gives one of those.
huh?
Gives one of those.
Orbital elements. What orbital elements? What do I give you?
Give us
R&B.
R&B.
If I say I have given you the plane, it means I've given you this. I've given you the orientation. I've told you what the orientation is. You see it? If the plane is given, what that means is the orientation is given to you. Just like, how do you find the position of a particle? How do you define the position of the particle?
Reference to where?
Hmm?
Reference to where?
Reference to a coordinate system, how do you define the position?
XYZ.
X, Y, Z. What are they? Huh? They are the distances or the position. That is a position vector, right? You define this go this much direction in X, Y, and Z. Just like that, three angles will define orientation. Just like three distances define position. If I say move x-axis, move so many degrees above x-axis, so many degrees about y-axis, so many degrees about z-axis, it defines the complete orientation of something.
Because if you have one, you do the inverse cosine and cosine.
Just like, think about this in the position context. You understand position, right? Just like you need three components of distances. To define positions, you need three angles, three components of angles to define orientation. How many degrees of freedom are there in space? 6. 3 position, 3 orientation. Okay? That is what it is. Any questions until now? Now what we are going to do is, there are going to be two computer-based exercises. Okay? I'm going to put it this way. This is going to be mandatory, but you're going to get extra credit. The reason you're going to get extra credit is it will help your grades. If I just give you points, it won't help your grades. You understand? You agree with that? You're right. You want extra credit or you want normal credit? Huh? You want everything extra credit. So this one, you're going to write a program. You're going to write a program in MATLAB, and I'm going to help you with that. Okay? It's important because once you go out there, you are not going to do all of this. You are going to do a lot of programming. They will expect you to know programming. And the more programming in you know, you're going to climb up the ladder much faster. Career-wise, programming it's like, it's a default. They think that you will know programming and they'll get you started with programming. Any company you go, it need not. So MATLAB is a very easy to program language or an application. There are quite a bit of MATLAB licenses up in the flight lab. Okay. So your inputs would be R and B. Okay. And your outputs would be, what would the output be? Huh?
H.
The orbital elements, all the orbital elements. H, A, E, theta, capOmega, I. So this is what your program will do. If your program, you write a program which will compute, given R and B, it will compute all of this. For example, how would you compute H in MATLAB? If you're given R and B. In MATLAB, your H is what? R cross B, right? The MATLAB equivalent of this is cross. So what I'll do is I'll write a simple line and tell you how simple it is. You define a variable H. You say H underscore vector, which means it's a vector equal to cross R underscore vector, comma H underscore. If you do this in MATLAB, VEC, that is your R vector and H, V vector.
So like by default, MATLAB can
Huh?
define space.
What?
Yeah, because it can do like matrices and stuff like that. So you can-
Vector is what? MATLAB can do arithmetic. It doesn't understand physical vectors. How do you define what is the mathematical equivalent of a vector? Huh? It's a matrix. What matrix? What kind of matrix? It's a It's a column matrix of order 1 by 3. So if you specify 1 by 3 matrix, you will specify that as a vector. That is how you identify your vector. You got it? So if you do this, if you say this equivalent of MATLAB code is H underscore, so these are just my variables, okay? You understand variables? You can define variables the way you want. It need not be this. You can define your name as well. Okay? And then you use this. This is a command which is specific to MATLAB. You say cross R underscore vec, comma V underscore. This is how I would do it. Okay? These two are given to you. Right? And in the initial part of the program, you're going to input this. When you do this, it's going to, this H weight will have a 3 by 1 column matrix in it, which is the angular momentum vector. Okay? And how do you calculate H scalar? You can either use square root or there is a command as well. You just use NORM H underscore vec. This will give you just this H underscore scalar will have just one number, which is this the magnitude. You see how simple it is to find one element. Once you do this, you can even validate your code. And when you do that, those special cases will introduce in your program. You understand? Can you do this?
And so it's MATLAB compatible with vector.
Huh?
MATLAB.
I mean,
Please look at them in big class. And give me a pen, please. less than 30, I would really warn you guys. Because everything was with you. Everything was with you in the textbook. And this is the only test where you got an open book. One of the things many of you have done is I had asked you to give me a circular orbit. What is the characteristic of a circular orbit? Huh? When you draw it, what is the characteristic of a circular orbit?
I didn't know.
Huh? It has the center, focus, and all are at the center.
Oh,
Because otherwise, what does it become? If you change your foci, what happens? It's an ellipse.
Is it a circle with this one?
Huh?
Is it a circle around with this one?
So that is very important. If you have drawn, even if you have drawn a circle, and if you've shown me F and F differently, it just means that it's not a circular orbit. Okay, and I've given you enough, wherever that's possible, I've given you points.
So, circle over you want the unoccupied focus at the same point too?
Yes, center, occupied focus.
everything is equal.
Huh?
Less than
Equal, yes. The last moment actually you asked me and then.
I never noticed the equal to part. I just, yeah.
That was important. Yes.
I did that first thing, I went
Equal.
back.
Huh?
I know, I'm talking way after I know.
If I had one time, I was
Class,
thinking
you told
greater
us
than
that
zero,
the
less than
point
one.
was.
I didn't even notice the little equal to part.
First I did well.
It's not supposed to be process.
I know, but you didn't say that in class. I swear you didn't say that in class. We were talking about this was like Nathan's not here. But I remember Nathan was like, because I know my mind was thinking it's a mess, and then you said the opposite thing. So that's my own one.
Yeah.
I mean, I understand.
I didn't know.
So if you are under 30, please be careful. It's very difficult to. It will be very difficult for you to clear or pass the course. Okay, I would. If you have your midterm, I have to give you your midterm grades today. I have given some of you midterm grades. Please check your midterm grades. If you have a D or F, please be careful.
I don't have it either.
Huh?
I don't know what it is.
Even if you don't have, I would like you to be careful.
Ready for this test?
You ready to suck up?
So then I asked you to get it.
You played it up? How many pages?
Too many.
Where's the work?
Research.
Huh? Where? Where? What's this so many pages?
How many words I printed out?
It's
It's like a lot.
I mean, like, because we have the printer bill, because I had bought back printer paper, so. So I tried to keep some with me in case there's
So what happened to you? Did a really nice this thing and
Every one of those slides has
I forgot
like
they were in I forgot 2 things on it. I forgot.
and then there's like 2 of them, it's not. Like,
One side for this, one side of the circle is 0, and the other side is
the
negative.
first slide,
I
the first
forgot
PowerPoint,
that.
and the last PowerPoint.
For the extra credit, I forgot for the circle, the center, and the both
The
sides.
first PowerPoint, the last PowerPoint, are only one slide to make it easy.
So what is it, like 4 different paragraphs?
Oh, you need
Yes. There's the director. the
anybody's
alternate
giving me
director.
hand? Have you given me anything?
Alright, so yeah, we got
You too.